Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Arif and I welcome you all to the third video lecture on the subject of computer organization and assembly language programming. The title of today's session is HDL for combinational circuits part 2. Well, in today's session we are going to design and write the HDL code for the XOR chip using the AND, OR and NOT gate chips that we designed in the previous lecture. We will do the interactive testing of XOR chip and then we will have a short class quiz. Today we will also see what is a script-based testing in comparison with the interactive chip testing. Finally, we will see what all players are involved in a hardware construction project. We have a lot to do, so let's start playing. Well, dear students, an XOR chip is a logic gate having two input bits and one output bit. The behavior of an XOR gate is the output is 1 if one and only one of its inputs is 1. This is in case of a two input XOR chip, and if we have a multi input XOR chip, the behavior will be it is an odd function. Well, this behavior is shown in this truth table. You can see over here and over here the output is 1 because odd number of inputs are 1. We all are very much familiar with the OR gate symbol that is shown. Now the question is how we are going to design this chip and implement or realize the design in silicon. Well, the design procedure will be from truth table we will derive the simplified Boolean function, and if you see the simplified Boolean function comes out to be this minterm plus this minterm, that is a bar b plus ab bar, and this cannot be simplified, I think. Then we need to design the gate level circuit for this function, and this is the gate level circuit. And then we need to specify this gate level diagram into the hardware description language. And if I show you the stub file, I have named the chip as XOR. The chip interface is it has two input pins A and B and one output pin, namely out. And under the parts portion we have the chip implementation, which is right now missing over here. Once we have written the chip implementation, we will test the chip in the hardware simulator, and of course the optimization and the realization part is not part of our course. Let me move on to the next slide. As far as the chip interface, remember these points that the chip interface is typically supplied by the chip architect. You being a developer are not concerned about the chip interface. This is given by the architect, and this is similar to an API or a contract which contains the name of the chip, that is XOR, the names of its inputs and output pins. We have two input pins, namely A and B, and one output pin, namely out. And then of course the documentation of the intended chip operation. So it is given that this has to behave exactly like the XOR gate. And now, being developer, we need to write down the implementation. So this is the implementation. I think this sounds very simple to you all. We have this NOT gate over here having in as input and out as output. This is represented over here. NOT in is equal to A and out is equal to not A. This is the name that I have given to this chip. You can give any name you want in which you feel comfortable. The other NOT gate, which is having the B as input and its output is not B. In is equal to B and out is equal to not B. Then we have this AND gate whose one input is A and the other input is not B. And having one input as A and the other input as not B, and this is the output. You can give any name to the output pin over here, and similarly the other AND gate is represented over here. And finally we have this OR gate, and these two internal pins are connected to the input of this OR gate, and finally we have the out. So this is one of the implementation. There can be other implementations as well you can think of. Here I have used the NOT, and the OR gates that we have designed in the previous session. You can simply use the NAND gates if you want to. Okay. So there are a bit of comments as far as the HDL are concerned. Remember, dear students, HDL is a functional or a declarative language. The order of HDL statements is insignificant. That is, you can write it in any sequence, these instructions. Before using a chip part, that is, these are the chip parts, NOT and the OR gates, you must know its interface. We need to know that the NOT chip has the interface of a single input pin, namely in, and a single output pin, namely out. Similarly, the AND chip has two input pins, namely A and B, and one output pin, namely out. If you know this, you can easily use these chips in your HDL code. Okay, so now is the time that we have written the HDL program for the XOR. So let's move on to the hardware simulator. Well, the hardware simulator is already running. Let me click the chip icon at the top left to open a window. Let me locate the XOR.htl file, which will be in the directory 3, because this is the third lecture. Well, we have loaded the chip now. In the last session, I talked in detail about this GUI. Let me describe these 4 pins quickly again. Over here is the HDL pane. This is a read-only pane showing the HDL code of the XOR chip, which is loaded right now. Above this HDL pane, we have the inputs pane, which is editable pane showing names and values of the chip's input pins, and the current values, of course, are also shown. And then we have on its right, we have the output pin pane, which is read-only, showing names and values of the chip output pins. And below this, we have the internal pins pane, and we have the internal pins pane, which is also read-only, showing the names and values of the chip's internal pins. And remember, as I said earlier as well, if I select any of the chip parts in the HDL pane, let me select this, and you can observe a table pops up in the internal pins pane showing the input and output pins names and their values for the specific chip part. Okay, so now let's verify the chip behavior by giving different values to the input pins, and tell the simulator to evaluate by clicking the calculator button, which is right now disabled. Okay, so right now it is 0 0. Let me give 1 over here, and if I give 1 over here, this is an XOR gate, the output should be 1. Let me execute it. Yes, the output is 1. Let me give 1 over here as well, and since now we have both inputs as 1, this is an XOR gate, the output should be 0. Let me click the evaluate button, the output is 0. So that's great. That is great. Fine. I think we have confirmed the behavior of this XOR chip. Let me fall back. Let me move ahead. Oh, okay. This is the time for a class quiz. Get ready. Okay, dear students, here is a gate level logic diagram of a combinational circuit with 3 inputs X, Y, and Z, and 1 output finally, namely out. The chip interface or the chip API or the stub file for this circuit, I have given you that file as the system architect. You can see the chip interface mentioned over here. However, the chip implementation code is missing. Remember, while writing the HDL code, you can assume that the NOT and the OR gate chips are available to you. And for your ease, their API is also shown over here. So please stop this video and try writing the code for this. I think you should be able to write it, and after writing that, you should be able to verify by loading and executing this in the hardware simulator. And meanwhile, let me move ahead. Well, dear students, by now you all are very much familiar as how to do interactive testing on the hardware simulator. Let us learn as how we can do script-based testing and why should we do it. Okay, so this is the code for the XOR chip, and we know how to load this chip in the hardware simulator. After loading this chip, we give the 4 different input combinations to the 2 input pins A and B, and we verify the output by checking the value of the output pin, namely out. Well, dear students, in case if there are more number of input pins, and thus more possible input combinations, so it might become cumbersome to verify the chip logic in the hardware simulator while doing the interactive simulation. The solution to this is we write down a script for this purpose. Well, a script or a test script, to be more precise, is a series of commands to the simulator. So here is a test script to the chip XOR.htl. The naming convention for this test script is to test the chip XOR or XOR.htl. We write the test script and name it XOR.tst. The first line in this script tells the hardware simulator to load the chip XOR.htl. Then we have 4 lines, 1, 2, 3, and 4. And these 4 lines are separated by a semicolon. Each line sets the value of the chip input pins A and B, and then instruct the hardware simulator to evaluate. So set A is equal to 0, B is equal to 0, evaluate. A is equal to 0, B is equal to 1, evaluate, and so on and so forth. So instead of loading the chip XOR.htl, we load this script XOR.tst in the hardware simulator. Well, this script-based simulation can be done with or without an output file, or with or without a compare file. Let me move on to the next slide so that I can explain the difference between these two options. Well, dear students, if you want that after the script executes, an output file should also be generated. If you want that once the script executes successfully, an output file should be generated, you need to add these 2 lines and this output command in your script as compared to the script shown on the previous slide. Well, this line says output -file xor.out, that is create an empty output file with the name of xor.out, and this line over here, this specifies the names of the pins whose values will be returned to the output file. Here we want that the value of the 2 input pins A and B, and the value of the 1 output pin out should be written in the output file xor.out. So this is how it is, and this %B blah 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 is actually the format specifier. Finally, we have the set eval lines, and over here we place another thing, that is the output command set eval output. Set sets the value of the input pins to these values. Eval evaluate the output, and this output command writes the output in this xor.out file. So once this script executes completely, the hardware simulator will generate this xor.out file in the current working directory. So if you want to generate an output file, add these red lines in your test script. And by red lines, I does not mean that you need to color them red. Okay, now we know about the output file. Let me talk about the compare file as well. Well, dear students, other than the output file, there is another file that is used in script-based simulation, that is called the compare file. The test script and the compare file are actually not written by the developer, rather they are given by the system architect. So you need not to worry much about it. You need to just concentrate on this HDL file. But for completeness, I think you should know how these test files are written and what part they play in the hardware simulator. Well, this compare file actually contains the already verified logic of the chip. So in the test script, we add this red line compare -2 XOR.cmp. Once when we write this, the each output command, that is this A0 B0 eval, each output command is compared to the corresponding line in the compare file. That is, this line in the XOR.out is compared with this line in the XOR.cmp, and this line in the XOR.out is compared with this line in the XOR.cmp. If the two corresponding lines are not same, the simulator throws a comparison error. If both the XOR.out and XOR.cmp files are same, once the script ends, you get a comparison ended successfully message by the hardware simulator. Okay, I think I have tried to explain it, but the things will not be complete until we mix our hand dirty on our simulator and do the script-based simulation of our XOR.txt file. Fine. So once our hardware simulator is running, let me run it again by closing this. Excuse me. So there are two ways of loading the script. One is click the file menu and click this load script. The other way is you can click this icon, document related icon over here. This will open this Finder window, and instead of the HDL file, this time I am loading the XOR.txt script. Load script, and there you go. Well, dear students, this time you can observe another pane, the fifth pane over here on the right, containing the script file, and these panes are empty right now because the XOR.htl file is still not loaded by the hardware simulator. Remember, dear students, this course part is taken from the book The Elements of Computing System by Noam Nissan and Shimon Skokhan. And I must pay thanks once again to both these professors for writing such a marvelous resource, marvelous book, written in a great way. Anyway, so this script pane over here in this GUI is also non-editable. If you want to make changes to the script, you need to load this XOR.txt file in an external editor, make changes, save it, and then load the script in this hardware simulator again. Well, just above the script pane, there are three down boxes of our interest over here: animate, format, and view. Over here we have this script, which is right now selected. If I select the compare, you see it becomes empty. So once I select compare, that means the compare file should be shown, and since there is no compare file right now, so it is empty. Then I have the output, so there is no output right now, and the screen is not related to us right now, so fall back to screen again. Well, as far as the contents of this script is concerned, I think I have already described the contents of this script. So let us see how we can execute this script. Well, dear students, there are two ways to execute a script in this hardware simulator. First is one instruction or one command at a time, and the other is execute the entire script in one go. So let me first execute this script one instruction at a time, and for this you need to click this button which says single step. Let's click it once. Sorry. So once I click it once, you can observe that this portion, this instruction of the script has been executed. The XOR file has been loaded, and we are on the second instruction, in which we will assign 00 value to the input and we'll get the output. Let me click it again. Kindly observe this portion. So no change. So now once the input will be 01, you will see the change over here. That's great. That's great. And in case 1 is given, you will find a 0 over here. That's great. Okay, once you're finished with the script, in the left bottom of the GUI over here, you can see the message comparison ended successfully. Let's see the contents of the output file and the compare file by clicking this drop down now. So this is the output file. This is the exact truth table of the XOR gate, and this is the compare file. This is the compare file, and this is the output file. So both these files are exactly identical. That's why our comparison ended successfully. That means the XOR chip is behaving perfectly fine. So my dear students, the script-based simulation of course pays because you don't have to put in the values in this pane again and again. You just run the script and you get the message. Okay, so now let me now try to execute the entire script in one go. Let me display the script over here. Let me use this reset button to bring the cursor back to the start, and now I will click this button, the run button. So once I click the run button, you will see that this script will be executed one instruction after another. I can also control the speed of the script execution by moving this slider. So let me keep it to a bit of slow so that you can understand things, and let me run it. You see it is executing one instruction after the other. And there you go. You can see the script executes till the end, and you see the message at the bottom, comparison ended successfully. Well, dear students, during the execution of the script, if you want to stop the execution, you can always do that by clicking this button over here, stop button, which is disabled right now. Since the script is not running, of course. Moreover, this scroller speed can always be controlled as per your desire. I think that is enough for script-based simulation on the hardware simulator. Let's fall back to the slides. Oh well, this slide shows the players involved in a hardware construction project. My dear students, there are two main players involved in a hardware construction project: system architect and the developer. The system architect actually decides which chips are needed, and for each chip the architect creates a chip API, the test script, and a compare file. And the task of the developer is that given these information, the developer has to write the HDL of the chip, and he has to later load it into the hardware simulator, and maybe write down the script or do the interactive testing, and generate the output file and compare it with this file. So these are the three resources which the developer has to do. That is the HDL file, and maybe the compare and the test file. But in this course, what will be expected from you is that you should be able to design the .html file, write down the code of it, and these compare and the test files will be provided to you and are available freely on my Bitbucket account. Okay, so dear students, that is all for today's session, and these are the tasks you need to do. Perform script-based testing of all the chips you have designed so far. You need not to write the script and compare files, as these are available on the course Bitbucket repository. If anyone of you wants to learn as how to write test scripts, tutorial of course is available namely test description language on the course website at arif.me. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning, and Allah Hafiz.